In this video, we're going to graph a more complicated example of graph that's exhibiting a phase shift. Okay, so we're going to pick this one apart. This has actually got quite a few values associated with it, but you'll notice that I've already set us up with a table of values to use to plug in to find what this spits out. Okay, so I'm going to go ahead and sketch in our friend here, if I can get my tablet straight here. So let's try this again. We say our unit circle. The circle centered at the origin of radius 1. This is going to kind of help us navigate a little bit here. But we say, of course, this tells us both the cosine and the sine value of any given angle quite conveniently. So we say 0, 1. This is actually incorrect over here. This is 1, 0, 0, 1, negative 1, 0, and then we have 0, negative 1. Okay, so let's go ahead and take a look at the example of this graph here. We're going to look at this example where we're exhibiting phase shift. Okay, let me see if I can click this, adjust the layers here. But we're going to exhibit phase shift, but in this case we say phase shift where the b value is not equal to 1. Okay, so let's list the values that we do know in this equation. We say the a value is 3, the b value is 2, we've got a c value of pi halves, and it doesn't look like we have any vertical translation, or we can say plus 0 out here on the edge, so no d value. Writing down what we know, we can say the amplitude of this graph. Since it is a sine curve, it does have amplitude, and we say it's the absolute value of 3, which is 3. We say is a negative, okay, so a is not negative, so in terms of reflected, yes or no, we say, well, it'd be no. In terms of what else do we know? We say it's period. The normal period of sine is 2 pi, so it's going to be 2 pi over its b value, which is 2. So this only has a period of pi when we graph this. Okay, and then we notice the c value here. Now, in the last video we looked at this, we said when I had like a positive pi halves here for c, what this did is it just shifted my graph to the right to the right pi halves units. Well, in this case, since we have a b value that's not 1, we have to take into account that that might change the way this graph behaves because it also affected the period of this graph. So let's go ahead and take a look at plugging in a few values here. I'm going to do a little bit of mental math, but we say negative pi fourths. If we were to take negative pi fourths and put it right here and here for the x, we'd get 2 times that, which is, let's see, negative 2 pi fourths, which is negative pi halves. So again, I'll show you right here. We're taking 2 times negative pi fourths. I'll just do it for this 1, and then we say plus pi halves. And so I want you to see what we get here. We get negative 2 pi fourths, which is negative pi halves plus pi halves. So we get negative pi halves plus pi halves. And I want you to see that this basically simplifies into 0. So we get 3 sine of 0. And I hate to spoil this for you here, but the way that I've got this set up and the way I've got these x values chosen is in such a way to just give us these values here. This is going to be sine of pi halves. This is going to be 3 sine of pi. This is going to be 3 sine of 3 pi halves when you plug that in and simplify it. And this is going to be 3 sine of 2 pi when you plug these things in. And the only reason I bring this up is because those are the 4 quadrantal angles we deal with. So we say sine at 0 is 0. So 0 times 3 is 0. And we say sine at 1, sine at pi halves, which is right here, is 1, but we say take that times 3, you get an output of 3. And then we say sine at pi. What's the sine at pi? We say sine at pi is 0, times 3 is 0. And then we know sine at 3 pi halves, which is down here. We say the sine value down here is negative 1. So negative 1 times 3 is negative 3. Then back to 0. So, what's different about this graph is that we start at negative pi fourths. According to what I have up here for our x values in the table, negative pi fourths, and then I go to 0. And then I say go to pi fourths, which would be the same distance as negative pi fourths away from 0, but on the other side. We say pi halves, that's another fourth of a pi distance away, and then we say 3 pi fourths. Be right here. So we could see some things here. We say that what's the total distance from negative pi fourths to 3 pi fourths? We could say, well, let's take 3 pi fourths and subtract off negative pi fourths, because that's the geometric distance there. We would just get plus a positive, it's 4 pi fourths, or pi, but we fully expected this because the period of this graph is pi. And then we say the amplitude here, it looks like to be a value of 3. We already predetermined this also. But you'll notice that our graph here starts at 0 at negative pi fourths. So that's here. Negative pi fourths, 0, 0, 3, so 0, 3 is here. And then we say now pi fourths is at 0, pi halves is at -3, and then 3 pi fourths is at 0 again. So here's our sine curve with an amplitude of 3 with a period of pi. But the thing is this. We full on expected that we were going to shift left pi halves because we're used to the c value as being dishonest, and it's in charge of horizontal translation. But noticing here that we had a b value of 2 actually affects this horizontal translation. So we shifted left pi fourths here instead of left pi halves. The reason why, though, is because what we're going to do is we would take what we expect, which, by the way, is pi halves, and then we'll divide it by b. Okay, so we say pi halves is what we expected. Divide this by b, and our b value here is 2. Okay, so another thing I want to mention about this is we would expect it to shift left pi halves. So this is going to be the opposite of pi halves. We're going to put a negative in front because we expected it to shift left. So far we've written this, we say negative the c value over the b value. And we can break this down and say in general we're always going to do it this way. Okay, so this is the conclusion we're going to draw here. This is what we're going to be calling phase shift. Let's go ahead and write this down now. Phase shift is negative c over b. We also call this horizontal translation. That's what this represents. So horizontal translation, what this represents. And these are the same thing. So negative c over b, let's see what we get here. We say negative pi halves divided by 2 is the same thing as negative pi halves times the reciprocal of 2, which is 1/2. So we get negative pi fourths. So this would say I went pi fourths units shifted, and I did it in a left shift fashion, left direction. Okay, so we went pi fourths to the left. All right, cheers.